Welcome. Today, we will look into the Algebra 1 Common Core Regents, the one that was given in January 2017. Alright, let's get started. Let's look at example 1 here. In example 1, this is the question. It says, which expression is equivalent to the original here? 16x squared minus 36. Alright, so one thing to notice here is that every time you've been given some kind of a big expression, try to see if you can make it into a simpler format. Let me rewrite the expression. All right, one thing to notice here is that you can factor out a 4. So just knowing here, you can factor out a 4 because 4 is a number that fits into 16 and 36. And if you factor out a 4, what you end up is with 4x squared minus 9. Now convince yourself that this is actually what you have here. 4 times 4x squared, it gives me 16x squared. And 4 times negative 9, it gives me negative 36. So we know we're good. Now, why did we decide to write in this one? Because now, at least, the numbers are more manageable. And notice here that now, in here, inside the parentheses, we can rewrite this as a difference of squares. So we're going to get some expression raised to the second minus some other expression raised to the second. Well, let's see what that is. 4x squared, well, we know that 4, you can write as 2 to the second, that is 4, and x squared was just x to the second. So notice that 2x to the second, that's 4x squared, and negative 9, we can rewrite as 3 to the second. Now, what's the purpose of this? Now that we have it in this form, we can rewrite this as 4 on the outside. And we can rewrite this as a difference of squares. So you get the first parenthesis, so it's 2x minus the second. So now this becomes minus 3, parenthesis, and you get the first one again, 2x, but now use the opposite, you do a plus. And if you notice here, this is our final answer. And if we look at the final options here, you will see that the correct option in this example is option 2. All right, so let's look at the next example now. Here we have what is the solution set of the equation, and the story equation equals to 0. All right, one thing to notice here is that if you look at how your problem has been written, this is what is called a factor form equation. This is a factor form. Now, once your equation is written in factor form, what you have to do is, well, grab each factor or each parenthesis and set it equal to 0. When two parentheses or two expressions are equal to 0, when they're multiplying, then you set each one of them equal to 0. So now you get x minus 2 equals to 0. Get the first parenthesis, set it equal to 0. Get the second parenthesis, set it equal to 0. Because we're looking for the solution, we gotta solve for x. So in this equation, you add 2. So here you have your first solution. And second equation, you add a 5. X is equal to 5. All right. So after here, if you look at your options, you will see that is option 3. Now let's see here. Here in example 3, it says, analysis of data from a statistical study shows that a linear relationship in the data with correlation coefficient. So here is a keyword, correlation coefficient. All right, we'll talk about what that is. So we know the correlation coefficient is of negative 0.5 to 4. Now, we want to see which statement best summarizes this result. So if we look at different options, we're looking to see, we're looking for the strengthness of the correlation coefficient here. Now, The best way to illustrate the strictness of the correlation coefficient is to, well, draw a line. We know that the correlation coefficient, it can only go from -1 all the way to 1. The correlation coefficient number, it's always somewhere between -1 and 1, where 0 is in the middle. All right. So now, one thing to notice here, well, since we're just concentrating on the negative side, so we're not going to pay too much attention on the right side, but we're going to pay more attention on the negative one. When it comes to correlation coefficient, I always like to just cut this into two. So the halfway between 0 and -1, that's -0.5. So notice that you just created two sections here, where the closer you are to 0, the weaker your correlation coefficient is. So in here, in this any correlation coefficient between 0 and -0.5, I would like to describe this as a weak negative relationship. All right. And the contrary about the other section. From 0 to -0.5, that's a weak negative relationship. So that means that from -0.5 to -1, this is strong, but still negative relationship. Again, when it comes to correlation coefficient, the farther you are from 0, the stronger your relationship is. So now let's look at where our correlation coefficient number is. Here they're giving us that it's in -0.52. So that means that, I don't know, it's going to be somewhere around here. So this is the -0.524. It's somewhere here. Well, let's look at the multiple choices here. We know that our correlation coefficient is negative. So those that have to have a positive relationship, we can just cancel them out. This one we said is a positive correlation. We can cancel it out. So now it's between 2 and 4. Now, option 2 it says there's a strong negative correlation coefficient. And option 4 says there's a moderate negative correlation between the variables. So now notice that this correlation coefficient that we've been given, it's somewhere in the middle. It's not too strong and it's not too weak, or the other way around. It's not too strong or it's not too weak. It's somewhere in the middle. And because it's somewhere in the middle, then we're going to say that this is some kind of a moderate negative correlation. So in this case, the correct option is option 4. All right, so now moving on. Let's look at example 4 here. It says Boyle's law involves the pressure and volume of gas in a container. It can be represented by the formula. Okay. When the formula is solved for P2, the result is. All right. So let's see what they're giving us here. They're giving us too much information, but honestly, all we need to just concentrate us is just the formula that has been given to us. So we have a formula. And also, here they're asking you, what do we need to solve? Now, if we look at here, and again, let me just separate this. Let's rewrite our formula. P1, B1, P2, B2. All right, perfect. So we have a formula. Now it says, in this formula, how can you solve for P2? This is a question. So let's identify P2, it's right here. So now notice that if somehow we will be able to just cancel out B2, if we can cancel out B2 and just leave P2 by itself, then we'll be done. All right, so let's think about it. How can you solve for P2? Well, one thing to notice is that here, you're multiplying. When you have variables next to each other, you are multiplying. So you have P2 times B2. We established that we needed to get rid of B2 because we know that B2 is multiplying. In order to cancel it out, we do the opposite. And the opposite of multiplication is division. So we will divide b2 to both sides. Now here they cancel. So now we have p2. Now in here, let's see, you cannot simplify this expression because notice that every single one was a different variable. So now you have p1, b1 divided by b2. And if you look at the correct options here, you will see that the correct option is option 3 because it does match p1, b1 divided by b2. And that's what happens when you solve for p2. Now, let's look at example 5. All right, perfect. It's a word problem. Let's just read it here. It says a radio station did a survey to determine what kind of music to play by taking a sample of middle school, high school, and college students. All right, so we're talking about 3 groups here. Let's continue reading. It says they were asked which of the 3 different types of music they prefer on the radio. So we're talking about 3 groups, and we're talking about 3 types of music. Either hip hop, either alternative, or either classic rock. Okay, and this result is summarized in this two-way frequency table here. All right, so now let's see what's the question here. It says, what percentage of college students prefer classic rock? Okay, so let's start with the basic here. Our question is asking us what percentage of college students prefer classic rock. At least when it comes to percentage, the way for you to find percentage is, I always like to call it group over total. Why do you want to find the percentage, or what group are you interested on, divided by the total? Now, in here, we want to find the percentage of college students who prefer classic rock. So in this case, our group, are those college students who like classic rock. So college students who prefer classic rock. Well, how can we find that number out? Well, let's look at this two-way frequency table. This row talks about college students. But more specifically, right here, 14. 14 are those college students who like classic rock. So at least for the group, we got 14. Because we want to find the percentage of college students who prefer classic rock. So we know that there's 14 students who are college and prefer classic rock. So now, for the total, here, the total here are the total of all college students. All college students here. Well, how can we find that number? Well, all we have to do here, we know that this is college students. We know that it's separated into 3 sections. So if you want to find the total, you just add them up. So here we have 16 plus 20 plus 14, which this is equal to 50. So now we have what we need. Now we can find the percentage because we know the value of the group and we know the value of the total. So here, our percentage is equal to the group, which is 14, divided by the total, which is 50. And if you do this correctly, you will get 0.28, where we want this in decimal form. And if you multiply this times 100, you will get that we have 28%, which is option 2. Perfect. All right. Let's see. We are in question 6 now. Question 6, we have the following. Let me just make it smaller so it fits in the whole screen. All right, perfect. So in question 6, it says, which function has zeros of -4 and 2? So let's start with, what do they mean by zeros? At least when it comes to graphing, the zeros are always located on the x-axis, always. Now the x-axis is the line that goes left to right, okay? So we have two ways to approach this problem. Let's look at those that already have a function, or already have a graph, I'm sorry. Let's look at those options that already have a graph here, and let's see when does our graph touch the x-axis. And at those points, we have zeros here. So let's look at option 2 real quick here. So here we have our function. This is our function. Now this is the x-axis here. Notice that your function touches the x-axis at these 2 points. Here's your function. It touches the x-axis at these 2 points. Now let's see, what is the value of the x's here? Here we have that x is -2. And here we have that x is equal to 4. So at least in option 4, in question 6, option 2, we have zeros at -2 and 4, which is the opposite of what we're really looking for. So this is not our option here. But now let's look at example for option 4. At what value of x does your function touch the x-axis? Oh, 1, 2, 3, 4. So here it touches at -4. And here it touches at x equals 2, because that's the value of x. So this implies that the zeros are -4 and +2 in option 4, because that's when your graph touches the x-axis. And that's exactly the zeros that we were looking for here, -4 and 2. So that's one way to see it. Let's say that this would not be the option. Another way to do it, to look at example 1 and 3, you would just have to graph each of those functions, and you will see where does your graph touch the x-axis. But we don't have to do that because we already see that option 4 is the correct option here. So now, if we observe in example 7, let me switch this up. All right, that's an example. Which expression is equivalent to I? So this might look intimidating, but all this is saying is just expand and simplify. Here, they just want to see if you know how to expand an expression and combine like terms. So let's look at this parenthesis at first. If we have a 2 in front, this implies that the 2 is going to get distributed. So let me rewrite the problem here, or at least the expression. 3g minus 4 minus 8g plus 3. All right, perfect. If we distribute this 2, we will get 6g. And if we distribute this, we're going to get -8. So at least this is what happens when you distribute the first parenthesis. So now we have a negative in here. And because we do have a negative, this negative distributes to both of them. So now this positive 8g becomes negative 8g. And this positive 3, if you multiply by a negative, that becomes a -3. So we already expanded. So now let's see if we can simplify. Look at here, we have like terms. 6g and -8g. If we combine those two, you will get -2, -2g, and you can combine -8 and -3. You do that, you get -11. So this is what happens after you simplify. And if we look at the options that we have here, you will see that the correct option is option 4. Perfect. So now, let's look at example 8. All right, so let's see what we have here. It says, in 2014, the cost to mail a letter was 49 cents for up to 1 ounce. All right, so you want to mail a letter, you got to pay 49 cents up to 1 ounce. The moment that you pass, or every additional ounce costs 21 cents. Okay, so you do have to pay 49 cents up to 1 ounce. The moment that you go beyond 1 ounce, you got to pay an extra 21 cents. Now, the question is, which recursive formula or function could be used to determine the cost of a 3-ounce letter in cents. Okay. Now here, let's just look at notation here. A1, you can consider this as some kind of a term and sequence. I'm sorry. You can look this as some kind of a sequence. Now, what kind of a sequence are we have? Because we have arithmetic or geometric. This is an example of an arithmetic sequence. Why is this? Because you start with 49 cents up to 1 ounce. Now, the moment that you pass that ounce, you gotta pay 21 cents now, and now you're gonna get a new number. So now this is 2 ounces. You want to pay another. Your letter weight's another ounce. Well, you gotta pay another 21. You want to pay another ounce. Well, you gotta pay another 21 cents. So notice that you start at 49 cents, and for every ounce you add 21. And because the common difference is 21, then we have an arithmetic sequence. Notice that the difference is of addition because you're adding cost. This is why it's an arithmetic sequence. And because it's an arithmetic sequence, when it comes to notation, A1 is the first term. And if it's the first term, it's pretty much what's the value that you start with when it comes to cost. So it doesn't matter how heavy your letter is, you need to pay 49 cents for up to 1 ounce. So that means that the first term in this sequence is 49. Knowing that A1 is 49, we can eliminate option 3, we can eliminate option 2, and we can eliminate option 4 because this is the only one that talks about A1 to be 49. So by process of elimination, we will see that the correct option is option 1. And again, what you do here is that we're adding costs, 21 cents to every single extra ounce that you will like to shift. All right, so now here, question 9. Question 9, it says, a car leaves Albany, New York, all right, that's cool, and travel west towards Buffalo, New York. So they're giving us an equation here. It says the equation D equals 280 minus 59t can be used to represent the distance. So notice here that D, capital D, stands for distance. So let me put this in a different color. The distance can be labeled as capital D. And also from Buffalo after T hours. So T is hours. Now the question is, in this equation, the 59 represents what? What does 59 represent? So if we have this equation right here, what does 59 represent? Now, we can approach this by process of elimination because notice that as we have it highlighted, we know that D stands for distance. And we know that T stands for time. Let's look at the options here. I mean, look at option 4. It says, does 59 represent the number of hours driving? No, because here they're using hours, and we know that T is for time, so 59 cannot represent time or the hours. Now, notice here that in option 1, it says the car's distance from Albany. But we know that D stands for distance. So that means that 59 in our equation here is not the D for the distance. It's a different term here. So we know that 59 cannot represent distance. The same idea for option 3. We know that D stands for distance. So that means that 59 cannot represent the distance between Buffalo and Albany. So by process of elimination, we can see that the correct option is option 2. If this was not a good approach, if we look at our equation here, there's a formula in physics, which it means velocity Okay. Velocity is equal to speed. Okay. Is equal to speed times the time. So notice that in our equation, what's in front of t, or the time? It's the speed right here. 59 is the speed because that is what's in front of t, which is the time. So that's another way to just see that it is option 2 as well. But this is a formula that maybe you're not aware of because you have not taken any physics class that maybe deal with velocity. But this is just another way to see it here. All right. So we're down to the last question for this part. Now it says fate wants to use the formula. All right, so we've been given some kind of a formula, and that is nice. So the formula states C of f is equals to 5 over 9 f minus 32. So we have a formula. Now, let's be careful what this formula does. This formula converts degrees into Fahrenheit. So this formula, what it does, it will go from degree to Fahrenheit. Oops, I think I misspelled it. So this is what this formula does. You plug in a degree, and it would, I'm sorry, this is not true. What this does is convert degrees Fahrenheit to Celsius. So it goes from Fahrenheit, and again, I misspelled it again. It goes from Fahrenheit to Celsius. Yeah, because it didn't make a lot of sense the first time that I wrote it. All right, it goes from Fahrenheit to Celsius. You plug in a Fahrenheit, and it will give you the equivalent representation in Celsius. All right. But now let's actually read here. It says, if Fate calculates C68, what will her result be? Okay. So let's look at what does this mean, C68. This means that if we look at here, look at how your formula has been written, and look at what you've been given here. All this is saying is, what happens when F is equal to 68? What happens when the Fahrenheit is 68? You have a formula. Look at what they're asking you here. So this is saying F is equal to 68, because that's pretty much what the formula is telling you right here. So let's see what happens. C of 68 is equal to 5 nines times, and again, here it says that F is 68. We have an F in our formula, so this becomes 68 minus 32. All right. So let's see what's this. Just plug in the calculator. 5 over 9, parenthesis, 68 minus 32. All right, so we get 20. So at least we know it's not 154. It's not 154. It is 20. So which one's it going to be? Is it going to be first or the second? Well, we got to see, what does this result mean? 168 is equal to 20. Oops. This means that we know that our formula, if we plug in a Fahrenheit, it will give you Celsius. So I know that this is Celsius. This is Celsius. So the correct option is option 1, because we did state that this formula goes from Fahrenheit and your results are given in Celsius. Look at our result. Our result was 20 and our results are Celsius. So this concludes the first part of our review for the Common Core Algebra 1 Regents review.